Welcome to MH class. Today we'll discuss about the maxima and minima. Actually, this is included in the chapter Application of Derivative, chapter 6 of class 12. Okay, let's see. It is so easy things if we go through it properly with the help of the diagram. Maxima and minima. Let's see. If we take a graph, then it will be easy to understand. See, this x-axis, y-axis, this is 0 origin. This is a graph, y is equal to fx. Now see, in the open interval, this is x is equal to a, this is x is equal to b. In this open interval, at which point, at x is equal to which point the value of, that is, this curve is extreme at which point, that we have to find out. Okay, suppose this is the point C, x is equal to C. At this point, this value, if we draw this way, we'll get this value is the extreme. After that, again it is smaller. That is, this is FC. The value of this is what? Y is equal to FC. At what? At x is equal to C. Then FC is the maximum value. FC is the maximum value of the function at x is equal to C. This is called maximum point. Maximum value at a point. Maxima at x is equal to C. Okay, point of maxima, or you can say point of maximum value. Point of maximum value. Point of maximum value. Where? At x is equal to C, and C belongs to the open interval within this interval. Similarly, that means what? See here, that FC is always greater than fx for all x belongs to a comma b. FC is greater than fx, okay, for all x belongs to a comma b. Then FC is the maximum value of the function at x is equal to C. Similar cases, if we see this one, and this one the function y is equal to fx. Now see, this in the open interval, in this open interval, this is x is equal to a, this is x is equal to b. This point, this is the minimum, the extreme value, this is the minimum value at what? At some point x is equal to d, some, that is d belongs to a comma b. That value of this function fd. So fd is the minimum value of the function. Okay, that means what you can say, fd is less than fx. Fd is less than fx for all x belongs to a comma b. For all x belongs to a comma b. This is the smallest one. So this is called the minimum value of the function. Fd is called the minimum value of the function in the function y is equal to fx in the interval a comma b. Okay. Now see, in some point of view, if we get this type of graph, See this type of graph. Okay, or you can take more also. This way you can take. This is x, this is y, this is origin. These are the points, and here the extreme, here is the extreme, here is the extreme. Okay, here is the, see, suppose this is C1, this is C2, this is C3, this is C4, this is C5, and this way it is given, and this is x is equal to b, C5, C6, this is x is equal to a. This is the point in the interval a comma b. In the interval a comma b, these are the points you are getting. These points are called critical points. Okay, now see, at x is equal to c1, at x is equal to c1, this is extreme. At x is equal to c3, this is also extreme. At x is equal to c5, this is also extreme. Among this, in this interval, if we say, among this, which is the extreme values? This is fc1, this is fc3, this is fc5. Which is the extreme one in the interval a comma b? Then this is will automatically will say fc. This case fc1 is called absolute maximum value. Fc is called the absolute maximum value. Okay, Fc is called what? Absolute maximum value. And similarly, if we see these three, this is fc6, this fc5. If we see the value, this is nothing but what? Which is the smallest one? The smallest one is nothing but fc2, and fc2 is called the absolute minimum value. Okay, and one more things, this is the tangent of the curve at this point, tangent of the curve at this point, and that tangent means what? Dy dx is equal to 0, that is f dash x is 0. This is also f dash x is 0. This also f dash x is equal to 0. This also f dash x is equal to 0. These are parallel to x axis. If we draw the tangent must be parallel to x axis. So this f dash x is equal to 0. And if we take f dash x is equal to 0, we will get the critical point. That point is called C1, C3, C5. These are called maximum point of maximum value, and C2, C4, C6. These are called point of minimum values. Okay. Now this is the basic things. Now we will get in the details. See what we will get in the details. The maximum value and minimum value. So what is this? Maximum and minimum. Maximum and minimum. What is maximum, minimum? Maximum and minimum value of a function. Whatever I told, that we will discuss now here. A function f is said to attain a maximum value. A function f is said to attain a maximum value at a point A. That should be the domain of f. That should be the domain of f. Okay? Clear? That is what? Domain of f. If fa greater or equal to fx for all x belongs to the domain, then fa is called the absolute maximum value of a. Fa is called the absolute maximum value of the function f. Okay. Similarly, a function f is attain minimum value at x is equal to b. B belongs to the domain of f. Okay. Domain of f. If fb is less or equal to fx, if fb is less or equal to fx for all x belongs to the domain of f. Okay. Then fb is called absolute minimum value of f. Then fb is called the absolute minimum value of f. Clear? Note, a function f may have maximum or minimum value in some parts. In some part. See, here already I told this one. Now if I say within the interval, this interval, what is the maximum? Maximum is f. In the open interval a comma b, we can take the local area. This is the local area c1, c2, c4. Here maximum is what? fc3, fc3. This is the maximum. That is called relative or local maximum value. Maximum value. This is local area, and this local area, not taking in the vast area, not taking in the interval a comma b. This part is taken within the interval a comma b, c2, c3 interval. Okay, c2, c4 interval. This is called relative or local maximum. Similarly, if we take this one, that this point c5 and c3, if we take, what is the minimum value? Minimum value we will take as c4, fc4. And c3 to c5, this is also a part of the open interval a comma b. That time how to say this is the relative. This is called relative or local minimum value. Relative or local minimum value. Okay, that is the thing. A function f may have maximum or minimum values in the some parts of the interval of the domain. Such values may occur at more than one point. It may be occur maximum and minimum values, but these are therefore called local or relative maximum or minimum values. Okay, local maxima. What is local maxima? What is local minima? A local maxima, a function fx is said to attain a local maxima at x is equal to a if there exists a neighborhood. That I told that neighborhood. This is the point x. Suppose this is the point x is equal to a. These points are neighborhood. The small changes are there. We are showing the largely we are showing here, but we take the small area of this within the interval. Okay, that is a plus delta, a minus delta, and a plus delta nearest to this one of a, such that fx is less than fa. Fx is less than fa. Then x belongs to a minus delta, a plus delta, x not equal to a. Then fa is the local maxima of fx at x is equal to a. If fx is less than, not less than fa, that is fa is greater than fx for all x belongs to the neighborhood a minus delta, a plus delta. Delta is small values. Okay, then we can say this is local maxima. Similarly, local minima is there. A function fx, is said to attain a local minima at x is equal to if there exists a neighborhood a minus delta, a plus delta of a such that fx is greater than fa. In case of maxima, what? Fa is greater than fx, and in case of minima, fx is greater than fa. Just reverse. And for all x belongs to a comma delta, a minus delta comma a plus delta, but x not equal to a, then fa is called the local minimum value of fx at x is equal to a. Okay. Test for identify the maxima and minimum value. What is the test? How to find out the maximum minimum value? First derivative test. First one is first derivative test. This is the important things. Step 1, find f dash x. Then step 2, take f dash x is equal to 0 and solve the equation to get the critical point. Suppose the critical point is c1, c2, c3, dot cn we are getting. Step 3, the sign of f dash x is studied. We have to observe the sign of f dash x in the neighborhood of each critical points. We are taking the example that one critical point is x is equal to c. If x is equal to c, what may be happen? The two things may happen. One is if the sign of f dash x changes from positive to negative. Sign of f dash x changes from positive to negative. Then as x increases through c from the left to right, then what will happen? This will happen. X is equal to c is a relative maximum point. This is called relative maximum point, and fc is the relative maximum value. X is equal to c is called relative maximum point, and fc is the relative maximum value. And if the sign of f dash x negative to positive, it is negative to positive, this is negative to positive, and this is positive to negative, plus to minus, and this is minus to plus, then x is equal to c is called relative maximum minimum value, relative maximum minimum point, relative minimum point. This is called x equal to c is called relative maximum point, and here it is called relative minimum point, and fc is the relative minimum value. Okay, fc is the relative minimum value. Next, this is the important test, and in general we are using this one, second derivative test, to find out the maximum minimum value. Step 1, find f dash x. First, to find out the f dash x. Step 2, take f dash x is equal to 0 and solve it to find out the critical points. Same, first step and second step same. Step 3, find f double dash x, second derivative, f double dash x. Step 4, find the sign of f double dash x and start it for all critical points. This, whatever the critical points are, this, all this we have to study here. Okay, suppose x is equal to c is a critical point. If x is equal to c is a critical point, and we get, it may be three conditions. If f double dash c is greater than 0, f double dash c is greater than 0, this is first condition, f double dash c is greater than 0. Then x is equal to c is a relative minimum point. If greater than 0, this is minimum point, and fc is the relative minimum value. And if second is what? If f double dash c less than 0, that is negative, then x is equal to c is a relative maximum point. X is equal to c is a relative maximum point, and fc is called relative maximum point, and fc is called the relative maximum value. And last option is what? If f double dash c is equal to 0, then what will get? Second relative test is fail, and first derivative test. Second derivative test is fail, and we have to use the first derivative test. Okay. Now, critical point. What is the critical point? What are the critical points? A point x is equal to c is called the critical point of the function fx if f dash c is equal to 0 or f dash c is infinite, does not exist. That is called critical point. Point of inflection, if fx is a function at x and x is equal to c is a critical point, fx is a function and x is equal to c is a critical point, then x is equal to c is called a point of inflection when, if and only if all the three conditions satisfied. That is, f dash c is equal to 0, f double dash c is equal to 0, but f triple dash c not equal to 0. So these things you have to keep in mind, and in general we have to use the second derivative test to solve the problem. Okay, first derivative test also we'll use, but in general we have to use second derivative test to solve the problem. Then if the concept is clear, we can use this concept to solve the problems, and next class we'll discuss about some problems. Thank you. Have a nice day.